You know, every so often, a single idea comes along that just changes, well, everything. In the world of AI, that moment happened back in 2017, and it was all packed into one perfectly titled research paper. Today, we're diving into the paper that pretty much lit the fuse for the entire generative AI explosion we're seeing right now.
So you're probably wondering, what was that big bang moment for the AI we know today? For things like ChatGPT and Midjourney. Well, the answer is right here, in this one paper and the incredible architecture it introduced, the transformer. Let's start by taking a look at the problem it was built to solve.
To really get why this paper was such a game changer, we first have to understand the huge problem AI was facing before 2017. See, when it came to understanding language, AI had hit a massive wall, a real bottleneck.
Back then, the big players on the scene were these models called recurrent neural networks, or RNNs for short, and they had one fundamental trait. They were sequential. They read sentences pretty much like we do, one word after another, from the very beginning to the very end.
Just imagine for a second trying to understand a really complex story, but you can only read it through a tiny little straw, one single word at a time. You'd have to hold the entire story in your memory as you go, right? That's exactly what these early models were trying to do, and as you can guess, it had some serious drawbacks.
So this created two huge problems. First, these models were painfully slow. You couldn't even start processing the 10th word until you'd finished with the first 9. This made it almost impossible to scale them up. And second, they were incredibly forgetful. By the time an RNN got to the end of a long paragraph, it had often completely forgotten what was said at the beginning. The field desperately needed a way to process everything all at once.
And that brings us to June of 2017. A team of researchers over at Google came up with this radical new solution in a paper that would honestly become legendary.
I mean, listen to this line from the abstract. It was just so audacious. They weren't just trying to improve the old method, they were throwing it out the window. Dispensing with recurrence entirely. They were proposing a totally new architecture called the transformer, and it was built on just one core concept: attention.
This is the key. This is the absolute game changer. The transformer architecture was designed to be parallel from the ground up. It looks at every single word in a sentence at the exact same time. This lets it instantly figure out the relationships between all of them, no matter how far apart they are.
Okay, so how does it actually do that? How can a model possibly understand a sentence without reading it in order? Let's pop the hood and take a look inside.
The secret sauce here is a mechanism called self-attention. Think of it like this. When you read the sentence, the robot picked up the ball because it was heavy. Your brain instantly knows that it refers to the ball, not the robot. Well, self-attention gives the AI that exact same superpower for every single word, all at the same time. The way it works is by giving 3 little signals to each word: a query, a key, and a value. So for the word its query is kind of like it's asking a question. Hey, who in this sentence could I be referring to? It then scans the key of every other word, which acts like a label. Robot has a key, ball has a key. When the query for it finds a strong match with the key for ball, it pulls information from the ball's value to understand its own meaning. And this whole dance happens for every word all at once.
But the transformer doesn't just do this once. Nope, it uses something called multi-head attention. This is like having a team of, say, 8 different experts all reading the same sentence at the same time. One expert might be focusing on grammar, another might be tracking who is doing what to whom. Then they all get together and combine their notes to form this incredibly rich, multi-layered understanding of the text. It's brilliant.
Okay, wait a minute. You're probably thinking the same thing I was. If the model is just looking at all the words at once, like they're just jumbled in a bag, how in the world does it know the original order? I mean, the dog bit the man means something totally different from the man bit the dog.
The solution is this really clever trick called positional encoding. Before any of the words get processed, a little piece of information, a unique mathematical code, is added to each one. It's like giving every word a timestamp. This tells the model exactly where each word is in the sequence, which preserves that all-important order without having to process them one by one.
So the theory was amazing. It was elegant. But did it actually work? Well, the results they put in the paper weren't just good, they were absolutely revolutionary.
The authors tested the transformer on machine translation, where the quality is measured by something called a BLEU score. Basically, higher is better. Now, the previous state-of-the-art model, which was this super complex combination of different models all working together, scored a 26.3. The single, big transformer model all by itself, scored a 28.4. Now, I know a jump of about 2 BLEU points might not sound like a lot, but trust me, in the world of machine translation, that is a massive leap forward. It was a total mic drop moment that made the entire AI community sit up and, well, pay attention.
And here's the real kicker. It wasn't just more accurate, it was way, way more efficient. As you can see here, it needed so much less computational power to train. The transformer got its record-breaking score using just a fraction of the resources. And that efficiency didn't just save money, it's the very thing that made it possible to train the enormous models that we have today.
Honestly, it is hard to overstate the impact of these results. This wasn't just a slightly better model. It was a completely new foundation for the entire field of AI.
By finally breaking that sequential bottleneck, the transformer unlocked the full power of modern parallel hardware like GPUs. It became the fundamental building block for pretty much every single major large language model that came after it. You know the T in GPT? Yep, that stands for transformer. And its influence didn't stop with text. This architecture has now been adapted for images, for audio, and even for biology and protein folding.
At the end of the day, the transformer gave AI a way to truly understand context at a scale nobody thought was possible. This ability to see the bigger picture, to grasp how ideas relate to each other across these massive data sets, that is the engine that powers all the generative AI we see around us today.
So, the paper proved that attention is all you need to unlock a whole new world of context for AI. And that leaves us with a really fascinating question to think about. If attention was the key to unlocking context, what's the next fundamental breakthrough that AI needs to discover to get to the next level?